afternoon. Good afternoon to the keynote session on this Friday afternoon. The keynote session is on software architecture for a digital age. A procedure issue, if you have questions, please note them already in the chat during the keynote. So we already have a list of questions when we get to the questioning phase. Data has been named the oil of the 21st century. And the question is, what about the platform for processing this oil? Here the question is, what will be the challenges and the architectural interactions with the platforms in our digital age? Eoin Woods is Chief Technical Officer of the technology company Eoin, and he has been active as an editor for IEEE software and as an author of a book and papers in software architecture. So we're looking forward to hear from Eoin. Welcome, Eoin. The floor is yours.
Thank you, Stefan, and thank you everyone for making time to be with me today at whatever point in the day it is in your time zone. Great thing about virtual conferences, we can be anywhere, can't we? So we've had people from all over the world, I think. Terrific. So my name is Eoin Woods. As Stefan said, I work for Endava. I've been there about 6 years and I'm the group CTO, which in a services company like ours, we do software engineering services. That means I'm responsible for our client-facing capabilities. Prior to that, I've done lots of software engineering, and I've tried to bridge the research and the practice communities for some time. So I've got a number of publications, and if you type my name into YouTube, if you're ever having problems sleeping, there are plenty of talks. I want to talk to you this afternoon for about an hour, hopefully a bit less, about software architecture for a digital age. So what do I mean by that? Everyone is currently undergoing a digital transformation, even people, it seems, who are moving their email systems to the cloud. Apparently even that counts as a digital transformation, according to certain vendors. However, when I talk about the digital age and I talk to clients and I have industry analysts come and berate me about the digital age, really from a software engineering perspective, the digital age is one of intelligent connected platforms. And what on earth do I mean by that? I mean computer systems, obviously, large software-based applications, which are characterized by a number of things, including the fact that they tend to be based on cloud, the fact that they tend to be publicly accessible, the fact that they tend to be built to be extended, sometimes by people in the same company, sometimes by people outside the company. They tend to be intended for long-term operation. They tend to be treated as products. Examples of these, the sort of granddaddy of these applications, in my view, is probably Google Maps. They were one of the first large-scale platform applications that was publicly facing. Inside Google, it's a platform that people from totally unrelated groups go and build applications on top of. It's highly data-centric. It's worryingly intelligent. Once it's stalked you for a couple of months, it's got a pretty good idea of your movements and then starts to try and give you personalized advice and so on. And since then, we've seen lots of other things emerge, such as Salesforce. Started off as a humble SaaS CRM system and is now an entire family of cloud-based platforms, which are all intended for both third parties and for Salesforce teams to build on top of. It's always on, it's highly scalable, it supports some of the biggest companies in the world, and scalability goes down, of course, some of the smallest companies in the world. Cushion are an example of a fintech platform. Cushion is an interesting company. They are trying to tilt the balance between the power of the institutions versus the power of the customers of those institutions. And one of Cushion's first clever features, this is very much about the intelligent platform, is for Cushion this is especially for the US market, they read your bank transactions. They connect to the banks and extract and intelligently interpret their terms and conditions, and they spot whether banks have overcharged you. And you don't even have to intervene. They then go and claim those charges back with interest from the banks for you. I mean, it's a very clever platform. And of course, it's intended that they can build lots of other applications on top of it. Intelligent Retail Lab is the Walmart sandbox, if you like, for trying out new digital ideas. And again, it's a data-centric retail platform, to overuse that word, which teams inside Walmart, and probably in the future teams outside Walmart, build applications on top of. And finally, a highly connected internal platform within Amazon is their drone control platform, which is still, of course, at experimental stage. A lot of it's being done near Cambridge in the UK. And this is where Amazon want to move to using drones for doing certainly certain kinds of time-sensitive, valuable delivery. And again, there's a platform being built within Amazon which allows other teams to then build software on top of it. So what are the characteristics of digital platforms? There's quite a few. Oh. Yes, I knew I had an animation. I'm not sure what went wrong there. In no particular order, these platforms they're always on. You just can't switch them off. They're in operation the whole time. Somebody somewhere wants to use them. They deploy very regularly, meaning that the software changes all the time. They tend to have parallel evolution, meaning there are a number of independent streams of development going on at the same time with relatively little coordination between them, all producing their own streams of software being deployed. They tend to have many user interfaces. So they have, for example, multiple web interfaces, consumers, risk managers, administrators, perhaps regulators, all have their own web interfaces. There'll be multiple mobile interfaces. There'll be API interfaces in from other systems. There'll be message-based interfaces. There'll be event handlers, but all of that has to call the same business logic. So the business logic has to be usable from very, very many different runtime contexts. They tend to go in unpredictable directions. These platforms tend to be driven by the reality of what is successful and what is not successful in their operational environment. Therefore, it's very hard to predict what the roadmap looks like. There isn't really a roadmap. There's a heap of ideas, and people start implementing ideas. They start measuring how the platforms are used, and then successful ideas win and get more investment and get developed further. Ideas that aren't so successful kind of wither and die. Sadly, often don't get removed, but they don't get any more investment. They're extensible by design. Some of them, like Google Maps, for example, is primarily extensible by Google's own teams, but teams who are not in the Maps organization. That's the important thing. And they're off doing their own thing at their own pace on top of Maps. And others like Salesforce, like the Salesforce Lightning platform, what used to be Force.com, is of course extensible. It's designed to be extensible by Salesforce's partners and customers. They're nearly always cloud-based. They're nearly always publicly accessible. We come across the odd platform in our work which is not really publicly accessible. It's in a fixed ecosystem, but an awful lot of them are publicly accessible. They're highly connected. Many of them have links into either lots and lots of consumer devices or lots of information sources or links into some kind of IoT network. People are starting to demand intelligent behavior from them. The Google Maps, slightly creepy, tells you how long it's going to take you to get home feature, being a great example. But if you look at any of Salesforce's hiring profile into their engineering groups, if you look at their marketing, if you look at what their partner organization is talking about, you can see that in bringing intelligence into the Salesforce platform is really, really important for them. And that's just one example. Nearly all the platform vendors are trying to bring intelligence into their platforms. What does this mean for us? Well, it's very clearly, it's highly multidimensional software architecture and engineering challenge. This is difficult. So what has the industry done in response? Well, probably before, in fact, we started talking about digital transformation, along came agile working. Agile working was the insight that fundamentally change is constant. We don't know where the end goal is when we start out. 5-year plans are a fallacy. We spend more time replanning than we do doing real work. So the core of agile working is being responsive to change. Breaking down our processes so that we deliver small increments regularly. We can learn from those increments and we can maximize value by changing direction. That's the core of agile working. The problem when we brought agile in, I was very much kind of one of those people, it was probably 15 years ago now, we started using agile really seriously. We found that actually we often couldn't get anything into operation. The reason being that the operational environment wasn't designed to be agile. It was a different group working in different ways. And actually, we couldn't get a new server for 6 months, and we could only release our software every 3 or 4 or 5 or 6 months too. So that was a big block. And then, of course, along came cloud infrastructure. So this was the boring old clouds that we had like 10 years ago now, I suppose, maybe even longer, where we replaced our servers and our storage and our networking and our API gateways and all those things with software virtualized versions running on public cloud. And effectively, the infrastructure teams kind of went, there you go. You see, you said we were the problem. We're no longer the problem. Let's see how good you are. And the application teams went, actually, we were bluffing all along. We can't actually release our software every 2 weeks. We were kidding you. We were actually sort of relying on the fact that you couldn't respond for 3 months to hide the fact that we couldn't respond. And it's partly because we're developing quite big things. And if I've got 500,000 lines of code, or even 100,000 lines of code, in a large single monolithic thing, call it a server, call it a service. That's quite a risky thing to change, and it's quite a difficult thing to test. So actually we don't move that fast because releasing this thing is a major undertaking. So then of course along came the idea of decomposing into smaller pieces. People like Sam Newman at ThoughtWorks, and Martin Fowler of course providing a lot of publicity for his ideas, and then the world's gone microservice mad now. If anything, I'm seeing the trend that people are moving the other way, actually, that they're having exploded their system into hundreds of microservices. They're going, oh, there were trade-offs. And all my architects going, who knew? Like, we didn't warn you at the time. But having exploded them themselves into lots and lots of microservices, they're now kind of actually bringing them back together to larger pieces. The point is, though, that rather than the good old days when we had a very small number of very big pieces, we can now choose the granularity and make the right trade-offs. And serverless is the latest iteration of this. I'm sure you've seen function as a service and all the public clouds, where you can now deploy a single procedure, really normally a message, an event handling procedure. Single procedure can be deployed by itself. That's about as fine-grained as it's ever going to get. And so that allowed us to move quicker in parallel because we no longer had to ship one big thing. We could put lots of change into one small thing and just ship that. The other thing that happened was reusable cloud services. Once they'd sort of cracked infrastructure as code, once they'd cracked IaaS type cloud services, the cloud vendors started thinking about how they were going to charge even more money for people to use their clouds because all that got commoditized. And the thing that they noticed was that there were lots of reusable services that people need. And lots and lots of people need, and they're often quite difficult to create. I mentioned one earlier, an API gateway service. Nearly everyone needs an API gateway service these days. But also there are much more exotic services such as IoT data handlers, analytics capabilities, semantic services for handling text and voice and graphics, all of those things. And this allowed us, you remember the thing about being data-driven and intelligent? This allowed us to move a lot faster. Let's be clear, there are not many software development teams out there that can build a sentiment analysis service for text quickly. I'm not saying they couldn't get there, but it's not going to be quick. Whereas today, they can have one in minutes. They can commission an instance of the Microsoft semantic service for text, and they can get a sentiment analyzer just through an API call. I mean, tremendous response to how we get sophisticated services into operation quickly. This was all fine. We can now move in quite fast and potentially in a flexible way with many different pieces. The snag being that through a lot of this, no one was actually talking to the operations group, who were still separate and were frankly not thrilled to have all of this change using third-party services with dependencies they didn't understand on a cloud they were fairly unfamiliar with. And that's, of course, what led along the way, not right at the end, but along the way, we've been developing the idea of DevOps. So by DevOps, I don't mean pipelines and I don't mean automation. I mean cross-functional teams where we have all of the different skills in a combined team to go from concept to operation and to keep it in operation. And I should mention, there is SRE as well. I will not get into the DevOps versus SRE and whether SRE is really DevOps debate. I don't think Google have been that helpful there, and I have my own opinions, but some people are using an SRE type approach, some are using a DevOps style approach. In both cases, the important thing is that operations are seen as part of the overall team. Even in SRE, they're still siloed off by themselves. What all of this has resulted in, though, is that our architectures that we're coming up with are expected to be much more fluid and evolving than they ever used to be. So what does this mean for architects who are actually trying to work in this brave new world? Because we have quite a few of them. The problem we'll see in this kind of simple graphic is that we've got Adriana, the architect, on the left, and she's working with a number of teams, and it's all very harmonious. And Adriana has sort of led the teams through a process of coming up with a fundamental architecture for the whole system. And they're building, let's say they're building microservices for the sake of it. So they're relatively independent. Each team's got a couple of microservices and they control their own storage and so on. And it all goes really quite well to start with. And they all start shipping change into production. But you may have noticed that software engineering teams are very rarely short of an opinion, and they're very rarely short of good questions. And so after a while, the software engineering teams start expressing their opinions to Adriana and asking her hard questions. The problem is that because they're working in parallel, they're all generating a lot of independent demands on her time. And eventually, she just becomes a huge bottleneck to the point where it all sort of stops. Well, one of two things happen. It all sort of stops because they respect Adriana, and she does know her stuff, and they don't want to wreck the system, so they don't want to move without her. But it's taking her a long time to get to them, or they just go, we'll just get on with our own lives, and away they go. And before you know it, you've got a massive scalability problem, or you've had a big security incident. The reason being that the individual teams don't really understand the system level approach to, for example, scalability or security. And the pressures on the architect as a result of this are high stakeholder expectations. Well, Google can do it. Why can't we? Well, possibly because you don't invest billions of dollars a year. Rapid technology change, especially on public cloud. I don't know if any of you get the AWS announcement email that comes out every month or so, but I shudder every time I receive it. The rate of change of the cloud-based services in all of the big clouds is not just Amazon, though they are the champions of change. The sheer rate of it is makes it very, very difficult for technical leaders to keep up. So there's a great danger that we're using things we shouldn't be using, because then either be deprecated or the cloud vendor doesn't want us to use them, or that teams discover the new services before the technical leaders do, and they don't really consult very well, and they just get on with it. We have highly distributed teams. I mean, in Dava, we've always had highly distributed teams in the sense that our Scrum teams were often in different places, all coordinating on one backlog, or maybe even multiple backlogs. Of course, the old joke, COVID-19 has done more for digital transformation than any chief digital officer ever has. We've now got the teams themselves being distributed. And that makes it all the more difficult for the architect to be heard, to influence, to lead, to mentor, to coach, just to take temperature, just to understand what's going on. It's a lot more difficult. All this parallel development, as we saw, is a real problem, because any stream of development at any point can have what they think is a critical, what they'd probably call a non-functional problem. And they come over to the architect and go, well, we need to connect to this and we don't know how to do it because the security model doesn't allow it. What do we do? And if the team's not empowered to solve that themselves, it becomes a huge interrupt for the architect. And finally, business pivots. Along with the Google do it, you also get we've up till now mainly been selling shoes in Southern Europe. However, the great news is we've got a business opportunity to sell outerwear, coats, in Canada. So if we could just put that on the platform, we'll start doing the marketing next week. The technical team just look at them and go, what do we need to do to sell outerwear in Canada? Business guys go, no idea. It's just like shoes, isn't it? It's just selling stuff, and they give us a credit card and we send them the stuff. And of course, then the technical people talk to real business experts and go, oh, Canada, let me tell you about the regulations in Canada about payments. Suddenly there's an avalanche of functional change to pivot a platform in a relatively minor way. Never mind businesses completely rethinking themselves yet. A lot of product type people, product thinkers in businesses, expect to be able to pivot, as they say, change direction very quickly indeed. The bottom line is that traditional software architecture is of less value in this environment, because you have autonomous teams producing a lot of independent activity, all wanting constant decisions made, and overloading a traditional sort of I make the decisions type architect who just starts blocking progress. As I said, the two outcomes are you get ignored or you block progress. Because we have it, and the other factor is that because we've got constant evolution, and because the destination is uncertain, at any point the destination is uncertain. Even if we think we've got there, there's always another destination. There is much less known early in delivery. So there's a lot less value in what I call upfront architecture, what the agile people like to denigrate as big upfront design. Well, for the first however many years of my career, at least 10, big upfront design was very respectable. It was seen as a sign of good engineering practice to do big upfront design. It's what people who built bridges did. And after all, therefore, bridge builders did it. It must be good for software. Well, actually, it's not so good anymore, because the trouble is, it's a bit like those 5-year project plans. If you do a lot of upfront architecture, you don't know where you're going. Therefore, the architecture will be in constant churn all the way through. And there's two problems there. One, you waste a lot of architect time designing and redesigning as things change. Second thing is you really confuse the teams, because they're not paying attention the whole time, typically, to architects who are producing models, trying to produce goodness. And every time they talk to the architect, it seems like something has changed. And they just get a bit bewildered as to what the value of this constantly moving target is. So actually, we've got to work out how to make architecture work valuable in a different way. So what do people do in response? Well, yesterday, I think it was, I presented a paper which is the result of some analysis and surveys of real architects as to what they do. And there's 4 things that they tend to do. They tend to try and understand and focus on stakeholder needs and priorities, because that gives them priorities and trade-offs. They do a lot of prioritizing of their time according to risks. They delegate as much as they can into the teams. That's got all kinds of good side effects, not least of which it frees the architect thinking time up to focus on the most important things that they want to prioritize through risk. And also they invest time to make their teams effective, because of course that allows them to delegate into them, but it also means there'll be less mishaps, there'll be less friction, there'll be less problems in the teams that will probably get the architect dragged into them to sort them out. And that was reported in this event. Interestingly, a number of people who'll be very familiar to this community, might even be here today, who knows, ADIXA, what was that, 2 years ago, now reported, again, some survey-based work, much more focused on 3 specific companies who work in the Nordics. I think this was all people who work with Jan Bosch's lab. And very interestingly, there were some real parallels there. The tactics that those architects said was they use modular loosely coupled architectures, very sensible. Ravi and I weren't asking about that. But they focus on the most important characteristics. In other words, they try and work out what's important, and then they really try and go and focus on that, and they just let kind of the rest go. And to allow them to do that, they move from controlling to facilitation. So a lot of parallels between the two totally independent studies, which were actually looking for slightly different things, but they've both come out with very similar conclusions, which I certainly, from my study, found reassuring. The theme of my talk today is really about an approach that is becoming known as continuous architecture. And it's one of the emerging responses to these challenges. I do stress it's only one. There's plenty of people thinking about this in other ways. I also stress it's emerging. Continuous architecture isn't a terribly kind of mature thing with lots and lots of books and lots of battle-hardened experience, but it is as much a philosophy and approach which a number of architecture approaches have either embraced or developed. So what is continuous software architecture? Great question. The first question is, do we need it at all? You won't be surprised from me in this community. Of course, the answer is yes, we're architects. What do you mean is it still needed? But actually, it's a very good question. If you go to companies like Facebook and Google, you don't find too many people called architect. In fact, you probably find no one called architect. So is there architecture going on? Yes. I mean, there's architecture going on. But why? If you don't have people called architects, why is architecture going on? Well, I think from my, and this is pure experience-based opinion, to be frank, there's 3 things really. Firstly, we've got to achieve quality attributes. Individual teams typically cannot achieve quality attributes at the system level. So somebody or some people or the whole team has to be thinking about how certain quality or the important quality attributes are going to be achieved, because an individual Scrum team just can't do that. There's also balancing stakeholder concerns. Some of the teams do a bit of this. So for what a particular function or a particular thing they're being asked to build, there probably are stakeholder concerns being balanced, that some combination of product owner and business analyst and engineer are sort of working together, the sort of 3 amigos are working together to try and work that out. However, my experience is that most development teams do not enjoy dealing with difficult stakeholders and balancing their conflicting needs. It's just not what they find fun. And also, again, it often has to be done at the level above the individual team. And finally, there are a lot of complex trade-offs in building a system. Just between all quality attributes pretty well conflict. Most stakeholders conflict. And every time we look at optimizing one thing, we're causing a reduction in optimization for something else. I mean, right through almost any complex system, there are complex trade-offs. So all of these are achieving cross-cutting concerns. By cross-cutting, I mean they affect most of the development team most of the time. But rather than being the way that I used to do architecture, which was trying to think a lot of this out up front, get structures in place to kind of save people from themselves and make sure that everybody understood the constraints they were working inside, architecture is now becoming much more a flow of decisions, and hopefully that's familiar. I'm certainly not the first person to say that. The characteristics of architecture work in the new world are that architecture is now a skill And it always was a skill, but it's not so much a role. That's why at the big FAANG companies, you don't find a lot of people calling themselves architects. They're all just software engineers. However, beyond a certain grade level, you're expected to have good architecture skills. My group head of architecture, Christina Bland, who some of you I think probably know, she's constantly trying to spread this message through our firm as we get bigger and bigger, which is she wants people in every technical discipline to have architecture skills. Yes, she's proud of her architects who have decided to specialize particularly in those skills. They're the reference point for the best practice in them, or the most effective practice in our firm. But she wants everyone to have architecture skills. And this is the way that we get architects to scale, if you like, into these very diverse environments. We make sure that a lot of the architecture work is done in the teams. Architecture becomes a stream of decisions. It's not something done and then tweaked through a development cycle. It doesn't exactly emerge linearly as you go. You do more at the front than at the end, but it is something that we make decisions about it all the way through the life cycle. We don't pretend that we can make good decisions at the beginning anymore. Rather than having a set of architectural structures which are defined and then sort of handed out to everyone to follow, today we're much more trying to identify the foundational styles in the system and understand the trade-offs that they imply and where different styles should be used. We're trying to give people or agree sets of principles, because principles guide people to make good decisions on their own. And finally, where we have detailed constraints that we want to impose, we use patterns to do that. Perhaps patterns realized as programming libraries. That's a very powerful way of making sure that people understand and use the pattern in a consistent way. But if not, simply a pattern. For example, you want every microservice to do authentication and authorization the same way. That's an excellent candidate for a pattern. Architects delegate and share wherever possible, something many architects historically have not been particularly noted for. They've not been very good at delegating. They've not been great at sharing. Now they have to get good at this. So communication skills, which were always important, now become very important. And also the focus on, do you remember about making the team effective? This is part of, we've got to share information and expertise with the team to make them effective. And we do architecture little and often. That's right through the life cycle. My challenge to architects is always every single Scrum cycle, sprint, what architecture work have you done that's been useful? And we aim for architecture to be something that everybody feels they own, rather than something that the architect over there owns. That is as unhelpful as the anti-pattern we see today, where there's somebody in the team called the DevOps engineer, or even worse, the DevOps. Everyone goes, oh, they'll be fixing the DevOps for us. It just makes no sense at all. It's like saying that person is the agilist. They'll do all the agile for us. I mean, it just makes no sense at all. And it's getting there with a lot of specializations, actually, but architecture is one of them. We want architecture to be a shared commons that people feel they've got ownership of, that they feel they've got accountability and responsibility for, because then they'll take it seriously and they'll use it. The continuous architecture approach, or sort of an approach called continuous architecture, has been around for a few years. My colleagues Mura Erder and Pia Pura, who are co-authors, wrote a book back in 2015 that was nothing to do with me. This is all their work, called Continuous Architecture. And I think it was the first serious attempt to take these ideas, which have been floating around for a while. Definitely not just me. Elchio Port, for example, has been talking about this kind of architecture work for a long time. Michael Keeling has been talking for a long time. George Fairbanks has talked about it for a long time. Simon Brown has talked about it for a long time, and many others. Pat Quah, for example. But I think they grabbed a lot of the ideas and tried to think them out well. And they wrote a book. An important part of the book is the 6 principles. One is that it's far better to architect products than run a series of projects. If you're building digital platforms, it's difficult to run it as a series of projects. The reason being is that projects imply short-term funding. They imply very fixed goals, which don't change after the project starts. And they often, in many environments, imply that personnel change at the end of the project. People rotate on, and you don't really want any of those behaviors. Principle 2 is focus on the quality attributes, in brackets, because no one else will. Functional requirements tend to take care of themselves. Now, Christina, my group head of architecture, would immediately jump in. She comes from massive scale payments. She helped to architect a system that in Britain pays my salary every month, called BACS. So it's a jolly important system to me personally. She points out that there are functional requirements which you need to get the architects involved with, because actually they're so difficult to achieve that they have an architectural significance. And she's right. She has examples like rolling back half of the UK transactions from last night because a reference data problem was found. Okay, Chris, I completely agree. That's pretty architectural. But for an awful lot of functional requirements, actually, Scrum teams are highly capable of doing a great job of building clean, flexible, modular code that implements functional requirements really well. The thing, as we've said before, that people really find it difficult to do is to achieve quality attributes at the system level. So that's the place for the architectural work to focus. The third one is this idea of the stream of decisions. Let's delay decisions until we need to make them. That's not an excuse for not making decisions. It's not an excuse for doing the first thing that comes into our head because we didn't see the decision coming. But it is acknowledging with a bit of humility that maybe we don't have all the answers until we've got the most information we can have. We will make a better decision with more information than less. So let's make decisions as late as we can. Architect for change. This is stressing the fact that these platforms change all the time, and a lot of the change is very unpredictable. So, and this, of course, is a cost, but this is part of continuous architecture, is accepting that cost, which is build change mechanisms, build an adaptability, build an awareness of change into the architectural work. Their advice here is leverage the power of small. Which is not maybe the way I'd put it, but I understand what they mean. What they mean is that insight about smaller services rather than huge monoliths. If you tend to build your system out of small, well-defined modular pieces, as the people in this study from the Nordics showed, it is easier to change a system than if you have a huge monolith where you have to ship huge pieces. There are trade-offs, of course. The key thing is getting the granularity right. When they say leverage the power of small, what small means completely depends on your environment. Architect for build, test, deploy, and operate. This is the insight that architects historically have kind of viewed themselves, software architects have viewed themselves historically as long as the code is a beautiful structure and can meet its quality properties in the test environment, my work here is done. Of course, you don't get any value. You get no points for completing your software in the test environment. The only measure of success is software successfully in operation. And so if we don't think about how software is built, tested, deployed, and operated, we are likely to run into problems. And if we can't get our software to operation, then we're not going to get those fast feedback loops that make digital platforms competitive. So it's important that we put enough effort into those as well as having a lovely software structure. And finally, model the organization of your team around the design of your system. There are actually many ways of doing this, and the continuous architecture book doesn't talk very much about the options. There's another book, which I'll point out at the end, which actually talks a lot about the structure of teams. The point they're making, though, is be intentional. The organization of your development teams and the work assigned to them, so the responsibilities they've got, has a direct impact on the way the system will be built and operated, for that matter. So make sure you do that intentionally. And how does this look? Well, it's quite subtle, really, because this diagram and the next one look quite similar. But historically, this is definitely the way I worked for many years, there are many stakeholder concerns, and the functional quality attribute, basically functional quality attribute, aren't they? I was about to say cost, and I think cost is a quality attribute. But we try and gather, trade off, understand stakeholder concerns, and then we largely do the architecture up front. And then we do iterative delivery. And often actually we're using agile methods in this cycle because we're hoping the architecture is not going to change very much. The architectural refinement, but we hope it's going to be quite small. And so we can be quite in a traditional environment, we can be quite flexible. We can be quite reactive to functional change as long as the architecture doesn't change too much. And that this produces regular, incremental, usable delivery, which can be put into operation as long as we have the downstream environment to do that. The problem with this is if we get changes which impact the architecture, we sort of have to go back a whole step, and it can be very disruptive because no one was really expecting the architecture to change very much. So the continuous architecture approach is a little bit different. We integrate architecture into the standard delivery cycle. We don't view it as a sort of big-brained exercise that's done up front to produce a lot of wisdom that's handed on. It's more that the architecture work, whoever's doing it, architects or everyone else, the architecture work is part of the standard cycle, and the architecture work is evolving as we learn right through delivery. So stakeholder concerns go into the entire cycle, if you like, and architecture is part of the cycle. An important side effect of that is that we get more knowledge as we go. And historically, there's been some research done in this community and others that we don't really store architecture knowledge very well in many cases. Certainly before I joined Endava, I mean, here I'm quite proud of the number of architects actually who are very good at storing architectural knowledge, particularly on Confluence or on wikis with a client or ourselves. But before I joined here, it's quite rare to find architects who thought about keeping knowledge. The continuous approach makes that very explicit. As we gain knowledge, we need to record it and we need to keep it up to date. The important thing is we're only storing useful knowledge. We're not generating reams and reams of architecture documentation that no one's ever going to read. We're storing knowledge because the knowledge is supporting the development team. And as we gain knowledge, we make decisions. And the other important thing is that we record our decisions formally. We've always said we should record decisions, but historically most architects didn't. Now it's rather nice to see that there's a sort of bit of a renaissance of interest in this. And again, people like Simon Brown, and even Neil Ford, Mark Richards, people who wrote the recent O'Reilly book, sort of the basics of software architecture, do talk about keeping architectural decisions. And so over time, we start with very little knowledge and very few decisions. And over time, we build knowledge and we build decisions. So when we've done many iterations of this, we hopefully are in a good place. We've got a lot of knowledge about the system's architecture, and we know what decisions we have made. And we're still creating incremental delivery. I need to at this point acknowledge that I have not quite stolen the diagram. I did draw the diagram, but I've stolen a lot of these concepts directly from Elcho Poort. There's Elcho's work with Hans van Vliet on risk and cost-driven architecture. I think it's been very, very influential in this. And of course, within CGI, it's their approach to how they do continuous architecture, in effect. Though their environment's certainly a bit different to one we work in Endava. So, I mean, this is very much synthesis of existing ideas. So what is it then that appears in that architecture bit? What are the important activities within continuous architecture? Well, I think they are to provide leadership, which I think has always been an important part of architecture, to focus on quality attributes, that's no great surprise, to drive architectural decisions. And I think the word drive is the key one here. The architect's role is not necessarily to make all the architecture decisions, it's to make sure that good architecture decisions are being made. So that's the difference. That's about empowering and coaching. Managing technical debt. One of the big problems with fast-moving software platforms is they amass technical debt quickly. Particularly when we're learning as we go, we're changing our mind, frankly, and we're changing the way that our architecture, never mind our detailed design, works. There is tremendous potential for creating a lot of technical debt. It's really, really important to manage that, because one of the key things people are looking for from us is the ability to maintain velocity. I'd say in all the client conversations I have about how can you help us, one of the most common things they want help with is understanding why their velocity is low and how do they improve it and how do they sustain it. And it's because they have teams who are perfectly intelligent, they're well-educated, sensible engineers who know how to do agile delivery. But for whatever reason, they've often not had very architecture-centric thinking. So what the architecture is a bit hazy, and they've ended up with a lot of technical debt. And that technical debt eventually just stops progress. And finally, we talked about learning as we go. We talked about the fact that we want to make good decisions based on more information. We need to build feedback loops in, both for the business, they'll ask for them anyway, because they want to know how many transactions are going through, who's using which bits of the system, what the profitability is, and so on. We need to do the same for ourselves. We need to implement feedback loops to allow us to measure the effectiveness of our software architecture. So what we're really trying to do is we're trying to move from an environment where we tended to do quite a lot of quite prescriptive design, sort of from a couple of great minds. That was always Fred Brooks's idea, was that it's one or two great minds produce great architecture. And I have greatest respect for Fred Brooks. He's the most marvelous thinker and human being who I had the privilege of meeting a few years ago. But I think this is one of the things I disagree with him on. I actually think for the kind of systems we build today, which are very different from OS 360, actually one brain doesn't really work anymore. So we're trying to go across to, as I said before, using styles and patterns to define the fundamental architectural structures, principles to help people make good decisions, and then recording our decisions in a lightweight, structured way so that we can continually go back and ask the question, why on earth did we use Angular to do this? Well, there's a decision. We did it for all the following. Oh, yeah, well, it kind of made sense then, didn't it? yeah, that was a terrible decision now. Oh, well, I feel we can do something about it because I understand the context in which we did it. Or why do we duplicate half the reference data? Oh yeah, I remember now, reading through the decision. Actually, we're going to continue doing that because if we don't, we have the problem that when it gets updated, we can't process any transactions. I remember now, yes, there's a good reason for that. I know it does sound like silly examples, but actually, over 3, 4, 5 years, an awful lot of the fundamental decisions just get forgotten because people's memories fade, people misremember things, or people move on. So we should end up with our team as a whole under the leadership of people who might be called architects or might just be called technical leads, but they have deep architecture skills, using styles and patterns, principles and decisions to create an evolving shared design, something that the team views as theirs and that hopefully they're proud of. It'll never be perfect. It'll never be quite what they want. It'll always have some technical debt, but hopefully it's a design and architecture that serves their needs and helps to make them successful. When creating artifacts, some years ago, 5 years ago now, I went to the XP conference as an architect. It was very much going into the lion's den. Luckily, I have a lot of friends in the extreme programming community, but I went to XP 2016 and I gave a talk on how to make documentation useful if you really have to, which I was surprised. It went down surprisingly well, actually. It seems that they don't all hate documentation after all, but they do hate useless documentation. And I came up with a couple of characteristics that I thought were very important for any artifact being produced. In particular, that they're minimal, so that they're easy to consume and that they're easy to maintain. They're usable. When you're writing it, you're not writing it for yourself. You're writing it for the person who's going to use it. You're thinking about how they're going to use the artifact. And they're significant. We don't just generate a load of documentation because it's comprehensive or it makes us feel that we're doing the right thing. It's actually, significant to someone. It's not something that could be just derived. For example, it can't be derived from the code, my favorite example. And then my good friend, Nat Price, he's half the team that wrote the Growing Object-Oriented Software Guided by Tests book. Nat was in the talk, and he came up afterwards and said, "You've missed 2 really important characteristics." And he said, sorry about that, but he said, on the upside, I have a brilliant acronym for you. And he said, well, things, once you've created them, you need to find them again. He said, lots of projects I've worked on, they've got a big wiki and a SharePoint and a dump a document somewhere, and they can't find anything after a couple of years. It needs to be indexed in some way. He's not actually saying it needs like an A to Z index. What he's saying is you need to be able to get the information back again. It's a really good point. I've seen that too. And finally, it needs to be checked. When you create it, check it's right. And every now and again, maybe after big system releases, or maybe you put a review date on it, go back and check that it's correct. That's what stops information bases, knowledge bases rotting, where you get to the point, I've seen this loads of times in large enterprises, where people say, oh, here's the architectural knowledge base. Yeah, it used to be really good. Oh, there's a lot in it that's wrong now, though. Have a read through it. You're the new person. Have a read through it and then come and tell me what you think you understand, and I'll tell you which bits are right and wrong. I mean, it's just terrible, so nobody consults it anymore. So yes, it's overhead, and that's why your artifacts need to be minimal and significant, because that minimizes the overhead of indexing and checking, but they're important. And of course, Nat was quite right. I got the lovely acronym music. And even if you create musical artifacts, then make sure that every artifact has an audience and make sure that every artifact has a purpose. I've seen an awful lot of very well-meaning documents written that didn't have an audience in mind. And even if they had an audience, they weren't really sure what they'd use it for. And you know what? They probably never got read. So it was a terrible waste of time, talent, and energy. So how does architecture address the kind of challenges we talked about in the digital age? Is it still relevant? So I'm postulating it is. Okay, so it's still relevant. Which aspects of architecture address which challenges? Well, the regular deployment, parallel evolution, unpredictable direction, a continuous style approach, which I think is more a philosophy than a tangible approach today, but a philosophy of continuous architecture really helps architects cope with this. If we've got publicly accessible systems, they're always on and they're cloud-based. Those suggest to me some really challenging quality attributes. Well, the architecture world's already got an answer to that: quality attribute tactics. We have catalogs of quality attribute tactics, which have been very well thought out over many years, and we can create new quality attribute tactics catalogs with relatively low effort. In fact, it's something we do in Dava, in our private architecture repositories that our architects share. So that's another thing architecture's got to offer. And how about all those kind of functional challenges, like all these different interfaces, and it's extensible by design, it's highly connected, it needs intelligent behavior. Well, architecture has already got catalogs of styles and patterns. And actually, these are very relevant. I've been quite surprised that people don't always know that they are called styles, but there has been a real renaissance in the software industry of referring to architecture styles. I mean, I have heard any number of conversations recently. Two senior technical people have been talking, and somebody goes, how does this work? And they go, well, it's basically an event-driven system, and it's got a blackboard, and we use, we use client server for the user interfaces. And you think, actually, you're talking about how you have combined architectural styles in order to achieve a certain kind of platform. So architecture's got a lot to offer. We need to evolve how we go about it to a more continuous style. But a lot of the historical wisdom, if you like, the quality attribute tactics, the architecture styles and patterns are still what are needed today. It's just that if we try and apply those in the context that we did historically, of trying to create a lot of sort of blueprint type models up front, we're going to get ignored and we're going to become irrelevant. We have to be part of the team. We have to be delegating, sharing, and empowering. We have to be moving to architecture being a shared commons. But actually, the techniques that we can use to achieve good outcomes still come from the world of software architecture. So to briefly conclude, Agile and DevOps thinking, I both think are marvelously positive. They change how we work. A number of technologies, such as cloud and containers, those are just poster children for the modern software environment, change how we build. What this means is that there's less point doing a lot of upfront architecture because things are more dynamic and change. And actually, they're easier to change than they used to be. Quality attributes, trade-offs, and stakeholders are not going away. If anything, they're getting harder. Expectations are going up. Technical environments are getting more complicated. Quality attributes are getting more demanding. Hence, trade-offs are getting tougher and tougher. But we have to move to some kind of new way of working. And I think it's best characterized by thinking of software architecture as a flow of decisions and a flow of guidance to a team to allow them to evolve their architecture. This implies real changes to how architects work compared to certainly my work career. In fact, maybe only 10 years ago, I was still, in some sense, handing out what I now jokingly refer to as the tablets of stone, making most of the decisions myself. This changes to how we work. And I'm proud to say many of our architects have gone through that transition very, very easily. It doesn't seem it's hard once people have got a mental model for the way that they're trying to work. And also, of course, it implies changes to architects' training. Many architecture books that we might give people, actually even some relatively modern books, don't really talk about this as a style of working. They either completely ignore how architecture should work, as in they talk about techniques or patterns or styles or something, but they don't talk about how to be an architect. Or they were written in a previous era when actually there's an implication that quite a lot of this is done up front. And I would immediately put my hand up and say, I've written one of those books. And thank you to many of you who may have bought a copy. I greatly appreciate it. So what we're trying to do in summary is we're trying to take the architect from being a historical purveyor of wisdom. This is very much how I saw myself 15 years ago, to now being someone who is at the center of the team as a trusted leader and advisor, who's helping the team get to good architectural outcomes. There's a number of books which I think are useful. Murat and Pierre's books are up at the top there. The one on the left is the original continuous architecture book. The one in the middle with the brown cover, as a result of it being in the Von Vernon series, is the one that I co-authored with them, where actually there were a lot of questions from the first book, which was, I kind of get your model, that first column. They kind of went, yeah, we get that bit. How about these tactics and styles and stuff? And so what we've done is we've talked a lot about quality attributes in the second book. My original book, I hold that up as the kind of one that some of it is now quite dated, but when we look back on tactics, styles, patterns, there's a lot of that is held in books like that. And that, of course, is only one example. But those books have still got a lot to offer, but we've just got to think about how we apply the knowledge in them in a new way. And then 2 pioneering books. One very pioneering book, George Fairbanks' Just Enough Software Architecture. George has been at this conference before. I don't think he's here this year, but his was one of the very first books I ever read where taking a more continuous risk-driven approach suddenly made sense to me. And it's a great book to get teams interested. A more recent one is from Michael Keeling, who was with us yesterday. I don't know if Michael's around today, but Michael Keeling's book, which is again very much in the same style. It's quite inspiring for development teams to see how they can actually take control of architecture themselves and apply architectural thinking in this kind of lightweight and continuous way. And finally, I mentioned that Principle 6 in continuous architecture is being intentional about your team shape. The book I referenced was Team Topologies. I'm sure a lot of you have seen it. It's actually come out of the Devops community, but it has a lot of good reference material, thinking and explanation for the implications of different team shapes. And that is Matt Skelton and Manuel Pais's book. And finally, there are a few websites. Continuousarchitecture.info, no dash, and continuousarchitecture.com, no dash, is the site for the Continuous Architecture and Practice book. Slightly confusingly, there is a continuous-architecture.com site that's completely independent. However, it's also interesting. It is run by a group of people who work at Michelin, the French company. They have invented their own approach to continuous architecture, inspired by some of these inputs and many others, and they have their own materials. They're sort of on friendly terms, particularly with Murat and Pierre, but have chosen not to simply adopt anybody else's approach. They've produced their own, and it's sort of semi-open source, so you can gain access to all the material there. It's a very interesting set of inputs as well. So thank you very much for your attention. I hope some of that made sense. I hope some of it was even useful, but we've got 10 minutes now, so you can tell me which bits weren't useful, and we can all learn from each other.
Thank you very much, Eoin. We have time for questions. And looking into the chat, I see a statement from Olaf Zimmermann. Olaf, please.
No, this was just hi. I was just providing evidence for a statement Eoin made about 10-15 minutes into his talk, that we see some companies or a couple of companies going back from the highly distributed, physically distributed microservices to modular monolith. Yeah, so, and there's a prominent software that some of you might know, the Service Mesh Istio. They've reported why they did this and how they did this. I was just supporting, providing some additional evidence for one of Eoin's statements. Not a question.
Thank you. I'd not seen that publication. I will go and look at that afterwards.
It's about 2 weeks old. It's in our column in software.
Excellent. I will check it out. Thank you. Yeah, Simon Brown likes to say as well. It said, if you can't build a modular monolith, what makes you think you're going to be a hit with microservices? It's sort of funny, but it's incredibly true as well. There've been a lot of people very optimistic that breaking their systems into small runtime pieces would somehow solve the fact that they didn't know how to design them to start with, and it hasn't ended well.
All right, questions from the audience, please. Eoin, when I listened to your talk, it was interesting about the team structure. In legacy software, oftentimes you can see that the design structure follows the organizational structure. So you have some responsibilities, and they are pretty, let's say, written in stone. And because you have the leaders and the leaders have their teams, something has to be kept like it was for a long time. And you suggest to turn this around and say, okay, we have some continuous architecting, things change, and we also should change our organization and the teams and so on. And I was wondering, what is your experience here? Does this work all the time often, or is it often difficult to convince the managers, to give off some responsibility?
So our experience with our clients is, and our clients are maybe not representative of all companies, because the reason they come to us and not, I won't name them, but a large offshore vendor, is because they want a certain style of system built. But of our clients, I think it'd be fair to say at the development team level, so say they've got 20 development teams, Scrum teams, all contributing in one business area, it's not very hard to move responsibilities between the teams and sort of pivot them to get them to work a different way. But I think the problem you're talking about is at the next level up, and that can be just impossible, where you want one, dare I call them, mid-level manager. I don't mean that insultingly. I just mean somebody who doesn't have the entire mission responsibility, but responsible for part of it, persuading them to give up part of theirs so that the teams can move into somebody else's part because they need to shorten the communication span, that's very difficult. People don't like giving up. Most managers, exceptional managers, don't care, because exceptional managers actually care about results. But there's a lot of people, halfway, 2/3 of the up management hierarchies who do benchmark themselves by the size of their organization and their budget, and they feel that if they've got 20 teams and they give 4 away, they'll be, whatever that is, 20% less powerful. It's a very old-fashioned way of thinking, but I agree with you. Most of our success has been within an area, and there's a group of teams, persuading the teams to give up responsibilities to each other so that they minimize the amount of communication between them.
Okay, so it's on the team level, not on the the manager level. Okay.
Yeah, pretty well.
I see.
I mean, we have had some organizations who've had we're very fortunate because we often build good relationships with quite senior managers, and then they move companies. We've had a few situations where a really courageous new CIO has come in and said, right, or divisional software engineering directors coming in and going, right, we're going to change this, and he just, or she, definitely she in one case, just shakes it up, and they do end up moving stuff around. But we've seen that's relatively rare.
Takes courage. Okay. Further questions? If I look into the audience, I know a number of people who should have a question.
I can see some hands up.
Okay. Can you see? If you can see a hand up, please then call the person you see yourself. Here. You have Ingrid.
Okay, so thank you for the great talk. I think it's very nice to hear and experience that with so many companies, and then you can share what is happening out there. But in your definition of continuous software architecture, the focus is on the decisions and this idea of breaking the system with this top-down view where you have the software partitioned into modules. It's not something that it's the key point of software architecture as in the past. However, from my perspective, this is something that many companies sometimes don't do. Like they don't have this model, this architecture model that we claim that it should have. And for me, it is quite important because that's how you partition your system. That's how you define flows of how to treat user requests. And in microservices architectures, it is fundamental because it's when you define how you're going to break your system into services and define the APIs and think about the modularization that is the low coupling. So for me, removing this idea that we must have this model with like the modular software architecture with the modules, it's quite dangerous, let's say.
It's quite scary, isn't it? I was talking to a client recently. They're a big insurer, and they have a particular chief architect who he and I have. So I work with our teams, and I work with some of his teams. In the interest of full disclosure, we have a certain amount of friction between us because he very much believes that you design the structure properly once, and the problem with people like me is that we're not clever enough to get the right structure, and if we just got the right structure, then we wouldn't need to change it all the time. I have a philosophical difference with him, and I think a lot of the systems in his organization illustrate my point because we suffer them because we work on them. It's very, I'm not suggesting that not having an initial functional breakdown, an initial structure, an initial set of decompositions isn't a good idea. In fact, it's critical because otherwise you can't break the system up. The thing that you've just got to always remember is that partitioning may need to change. You won't get it right for the long haul in the beginning. So we see this all the time, is that so our teams will start creating a system. We built a system for a huge logistics company where we built a kind of digital front door for them that hid all their legacy systems and allowed them to take bookings and people to get freight rates and all that stuff. And we worked with their business domain experts. We partitioned it up into quite big microservices. They were quite chunky. They each had a decent sized Cassandra database, a lot of state in it behind them. And what do you know? We almost got it right, only within 6 months. One of them had to be partitioned because it was quite clear that we'd mixed concerns, and another one we got. I think it was at least a dozen services, but at least 2, maybe 3. Turns out they were so chatty between them. It's very clear we just misunderstood the domain. And actually, what was happening was this was actually in domain-driven design terms an aggregate. We'd managed to split an aggregate across a couple of microservices or services, so they had to be slammed back together. So yes, it's worth doing enough design that you know what your structure is, but don't kid yourself that you're going to get it right at the beginning. That's why the architecture process stays continuous.
Thank you very much.
Thank you. Patricia, please.
Thank you. So I hesitated to pose the question because I was teaching in overlap with your keynote. So I just heard the last 5 minutes or so. So I will go back to the YouTube. I'm sorry about that. But I was triggered by your one of the concluding slides in which you commented on the tactics. Mm-hmm. And so to organize the team and to build stuff. And we are starting a project in which my idea was is to extract architectural tactics from the experience of the architects from a number of organizations. Mm-hmm. But did I understand correctly that you think that tactics is maybe not the right instrument to be usable or used effectively in practice? Or
no, I think tactics definitely are. As long as they're modern, relevant, current tactics, I think they're definitely the right tool. What I was arguing was that historically we used to apply tactics. I mean, our book tells you to do this. You know, when you're designing the structure, you apply the tactics, then you get it right, and then you can just build it. Whereas actually, I think tactics are still really valuable, but you might be applying tactics, right through the evolution of your digital platform.
But in your experience, how broadly are they used in practice?
Tactics are used informally. So a lot of this stuff, which has been very, very well thought out in research, as you know, Patricia, we've talked about this many times. Some of it's used in industry. I mentioned styles. Now, I'm not sure that many of the people referring to blackboards and repositories and event-driven architectures actually know they're talking about styles. I always use that term, but then people in Dava think I'm very old. So gloss over all that kind of thing. I'm not sure they know they're called styles, but they're aware that they exist. And actually, I have seen some very kind of industrial writing on places like InfoQ, which has mentioned styles recently. So some of it, the terms are familiar. But if you show people architectural tactics and you don't put tactics at the top, you just say advice for security, people go, yeah, that's really useful. This is all stuff I didn't really know or I'd forgotten. They don't know to call it tactics because that's a particular term that the research community coined for this idea. And if you haven't done the SEI course, or they haven't read their book, or they haven't studied architecture at VU, they won't know the term. But it doesn't mean that they don't need advice. In fact, one of the things people have repeatedly said about our book was they really like the amount of practical advice there is for achieving qualities.
Okay, yeah.
Which they always call
confirms also my experience, but okay. Thank you very much.
No problem.
Thank you, Patricia. I know we are going into the break, but as it's a virtual conference, I think the discussion is very interesting. We'll just keep going on as long as we get questions, and the next session has not begun. So next is Welf, please.
Thanks for the great talk once again.
Thank you.
I was inspired by you saying that there are architectural skills or architecting skills that developers, programmers, and other parts in software engineering should have. And my question would be the other way around. To what degree you think a good architect would need programming skills and needs to be in touch or in connection with the daily work of a software developer? Well, if you say this is not so important, then you might be all good. But if this is also important, then maybe we are in trouble, right? Because we promote the good software architects to be further and further away from core development teams and make them worse and worse software architects. So that would be
It's a really good question. I think the architect. So I wrote an IEEE software opinion article on this a number of years ago now called "What's Your Return on Investment?" Or should architects write code? And I said, well, if you look at your working week, it's got 40 hours in it. What's the return on investment for different amounts of coding? And for some people, they could spend 20 hours a week, and it's the best thing they could be doing. For me, when I got to a certain level in the bank and I had 650 engineers, I was responsible for their work, my ROI started falling very steeply after the first couple of hours. So I think the really key thing is that we don't become what are pejoratively called PowerPoint architects. If architects don't have the skill to, clone something off GitHub, build it, and read the code, understand it, critique it, and work out if it can be used, they need to find another job. I mean, they're probably very skilled people who are valuable, but maybe they're domain experts or SMEs or technical project managers. They can't possibly be making really good technical decisions, which the teams will believe in, because they'll get tripped up by silly things like, MongoDB doesn't persistently commit transactions. Well, they didn't know that because they've never downloaded Mongo and they've never actually, read the guide or done the certification. So they can't possibly. I mean, the way I look at it is, you've got to have enough technical knowledge to make good decisions and be credible to the teams. That's my goal 5 days a week, is to keep just enough technical knowledge to do that. And most of our architects in Dava, even the ones in the architect career family, we've got a few EAs who they would be the first to say we're not very close to the code anymore. But all the rest, they're quite capable of, fixing a unit test. That's quite a good, differentiator. Can you fix a unit test? Because if you can't, you probably need to do a bit more technical work.
Thank you very much. I agree, of course, yeah.
Good.
Andreas, please.
Yeah, okay, yes, thanks for the talk. So I worked in the past in the automotive domain, and we were doing some kind of continuous architecting, but we never said it's continuous architecting. So we did no upfront architecting, but the architecture work was feature-based, right? So we created feature A, the architecture for feature A, then it was delivered, it was deployed, and so on. And let's say half a year later, we developed feature B, and we identified, we missed some dependency on feature A. So we changed feature A a little bit. Then feature C came up. We missed another dependency, so feature A has to be changed again. And it seems to be a continuous process. And after 2 or 3 changes, the architecture of feature A was so bad that you could basically throw it away. So, so do you have any guidance on that? How we could avoid that?
Was a great question. I'm not quite sure what sort of software it was. I do stress that I'm talking about large cloud digital platforms. I'm not talking, for example, about ICE, in-car entertainment systems for luxury cars, for example. I don't know about that domain, and it might or might not, respond to this kind of work. But but in the digital platforms area, what you describe is quite familiar. I mean, we end up with, this is why the managed technical debt is a really important part of those architecting activities. I mean, you as you adjust things as you go, you absolutely can incur real technical debt. It sounds as if what was happening was, because you were working on feature B was funded, and it had a deadline, and probably not enough money. Most of the effort went on feature B, and then everyone realized that that bit they'd built for feature A wasn't quite going to work. So they did the minimum work possible to slam a change into feature A so feature B could get shipped. And that's fine. If you've got an industry deadline, like we've got to have this by the Geneva Car Show, well, you've got to have it by the Geneva Car Show. But I think where it goes wrong is that then it's normally the product management group don't say, well, let's just think about this. We agreed to cut a corner really badly there. Can we go back and look at the stuff for feature A? Because I guess you guys have really messed it up now, haven't you? What state's it in? And then sort of manage that so that this investment goes back in to get feature A back into a respectable state. That, in my experience, very rarely happens. Partly because product people can be really difficult, but also that just, I don't think, or I've observed that certainly I have not spent enough time trying to explain the implications of trade-offs to business people and product people. And it's one of the things I found I was working for a big bank. One of the skills that I did have to develop there, but was very valuable, was explaining what a technical cut corners implications were to a business person. The fact that we'll do this now, we'll get you your regulatory change in. This will mean next time you want to change the pricing algorithms, it'll take us 3 months. It normally takes us 2 weeks. Do you understand? Now, they sometimes forget, but you can remind them. Do you remember the conversation? Yeah. We were in your office.
Yeah,
I told you.
That's a good idea. Thank you.
No problem.
All right, last question from Bradley, please.
Hi, Eoin. Great talk.
Hi,
Very inspiring. So my question is more, I guess, coming off of Ingrid's question, what I thought Ingrid's question was about is that not all architecture decisions are the same, right? Some are fundamental, they're more load-bearing, and some might be easier to change, like the paint color on a wall. Do you treat those differently in a continuous architecture approach, or does it all kind of fall out in the way you deal with each architecture decision?
Well, I think you look at your architecture decisions and think about impact, particularly impact of getting them wrong. And the stuff that has relatively low impact of getting wrong, you push into the teams. You say, our log, take a trivial example. It's quite clear that our logging infrastructure at the moment is a bit of a mess, and ops can't mine anything out of it in Splunk. And do you remember the last incident? It wasn't a pleasant situation because we couldn't trace stuff through. Could you go and figure that out for me? Because if they get it wrong, well, it's already not very good, and we just won't implement it. We'll figure out something else out. On the other hand, when somebody comes and says, I don't know, it appears that we need to support an entirely new business domain, and we want to do it by not changing the data scheme in the database. You go, oh, just a minute. Can we just everyone stop and take a look at this? That's got really big implications. I think that's the way I'd handle it.
Okay. Thank you very much.
Welcome.
Thank you, all the people who discussed questions. Thank you very much to Eoin. And with this, we conclude the keynote session, have a very short break, and move on to the next session at 4:45. Thank you very much.
Great. Thank you all. Bye-bye.